Hello students. Hello students. In this class, we'll see the triangles second exercise, third exercise, questions 2 to 6 solutions. Okay. These are based on the three criteria, similarity criteria, AA criteria, SSS and SAS criteria. AA is also called as AAA. Okay. Let's see. Second one. In the figure 6.35, ODC is similar to OBA. Okay. Few angles are given and few angles they've asked. Draw the figure. Two lines here. DC, BA, O. This is 125. This is 70. Okay. We'll say given. What is given? Triangle ODC similar to triangle OBA. Write the given angles. BOC is 125. CDO is 70. To find DCO, sorry, DOC first, right? We'll write that only. DOC, DCO, and OAB. We have to find these three proof or solution. We can say proof. If you observe the figure, COB is 125, DOC they asked DOC. So just I'll extract the things. BCDO. This is given as 125. DOC is how much? Since it's a linear pair, we can calculate that. Check out. We know DOC plus COB equal to 180, say linear pair, right? DOC is equal to 180 minus COB is nothing but BOC, both are same. So 125 becomes 55. First angle is 55. Okay, because 25, 30, 80, 55. DOC is 35 to 55. Then DCO they want. DCO means in triangle DCO we have two angles known already, 70 and just now 155 we found. D is given, DCO we found 55. Therefore, by angle sum property we can find DCO. This is done. Therefore, in triangle DOC, DCO equal to 180 minus DOC plus ODC. We say angle sum property of a triangle. 180. What is DOC? We just found 55 plus. What is ODC? ODC is given. Check out. ODC and CDO are same. 70. 180 minus 70, 120, 125, which comes to again 55. Okay. Now last one is OAB. OAB, don't calculate OAB now because they have given a hint. ODC and OB are similar triangles. Since ODC and OBA similar triangles, ODC angle value will become OBA angle. Therefore, we'll say OBA is nothing but ODC value. That is ODC, we have the value ODC 70 only. We say triangle ODC similar to triangle OBA. Therefore, OBA we want, we just extract that from the above statement. OBA equal to 70. Sorry, OAB, right? OBA, OAB. OAB is equal to how much? OAB and ODC are same, 70 degree. Okay. 125 is given and 70 is given. Yeah, perfect. Okay. This only similar triangle knowledge is used in the calculation of OAB only. Normal DOC we found by linear pair, which we learned in the previous classes. We'll move to the next question. Third one. Diagonals AC and BD of a trapezium ABCD with AB and DC parallel intersect at O. Using similarity, we have to prove the ratio. So first draw the trapezium. Figure is not given there. We draw a trapezium ABCD. They said AB parallel to DC, right? And they intersect, the diagonals intersect at O. We write O for the intersecting point. Okay, we have to prove OA by OC equal to OB by OD. Very simple actually. We need either of AA, SAS, SSS. Since it's a trapezium, we can use alternate angles concept and we prove that. Let's see. In triangle, no, sir, given we write first and to prove, like that we'll go. Given, what is given? ABCD is a trapezium. AB parallel to CD. That's it. AB and CD intersect at O, no need to write. To prove OA by OC equal to OB by OD. Proof. You take the triangle AOB and COD. AOB, AOB and COD. Let's see. In triangle AOB and triangle COD, AOB and COD, we know this and this are alternate angle. These two are alternate angle because the lines are parallel. By parallel line concept, alternate angles are equal, corresponding also equal. Since it's a trapezium, we get only alternate angles. Corresponding angles will not be applicable here. So we just write properly. In triangle AOB, what is OAB equal to OCD, alternate angles. We'll write one more and then write the reason together. OBA is equal to ODC. Check out. A and C should be equal. A and C should be equal. So the reason for together is alternate angles. Once we have alternate angles, we can stop and say those two triangles are similar. But we have one more available. What is that? AOB equal to COD, that is BOA, right? Vertically opposite angles. Therefore, triangle AOB similar to triangle COD by AAA similarity. Once we have similar triangles, the ratios are equal, we can write. What is to be needed? Just write OA by OC equal to OB by OD. If you remember, when we used to write in congruent triangle concepts, CPCT, corresponding parts of congruent triangles. Here, it changes to corresponding parts of similar triangles. Remember that. Okay. You write the complete statement there. Corresponding sides of similar triangles. Okay. Corresponding sides of, how do you say corresponding? Just check out. I'll complete and then explain. Corresponding sides of similar triangles. See, how corresponding? See, you are taking OA. Now OC will come. See, OA by OC. OB you are taking. OD will come. Okay. So that's it. That's what we want to prove. Say hence forward. Okay. Very similar. Very simple. You have to identify whether AA comes, SAS comes, or SSS comes for similarity. We'll move to the next question. Fourth one. In the figure 6.6, they have given the figure. I'm not drawing it. You have to draw while solving the problem. QR by QS, see, QR by QS is equal to QT by PR they have given. Actually, they should give QT by QP. Then those two triangles become similar because they're the corresponding triangles, parts of the triangles. See, what they have given, QR by QP they have given, this one. QR by QS is QT by, actually they should give QP, but instead they have given PR. But QR, QP, QP and PR are equal. If you check out the angles in the QPR, base angles are equal, then angles opposite to the sides are equal. Therefore, PR becomes QP. There we are done the problem. Okay, we'll see that. Given, just write QR by QS is equal to QT by PR. Angle 1 equal to 2. Angle 1 equal to 2, where QPQR it is. Okay, in triangle PQR, they have given angle 1 is equal to 2. What is angle 1 and angle 2? If you remember the inequalities of triangle, if two angles are equal in a triangle, then their opposite sides are equal. We'll just complete that and we'll before we move ahead. One opposite angle is what? In the PQR, opposite side is what? PR. Two opposite side is PQ. You write the reason. Sides opposite to equal angles are equal. We call this as 1. We need that. That's why I wrote just in the given. You can write in the proof also. To prove triangle PQS similar to triangle TQR. Proof. See, in triangle, whatever it is given, you just pick it. PQS and triangle TQR. See, PQS and TQR, we have the angle CQ same. Common angle. The other two ratios will come. Ratio actually we can use here, but actual ratio is what it should come is, if you observe the triangle what we have written and what is given, QR, see, QR by QS, QR by QS, right? QR by QS means I should write here different because I took PQS first. So I can write QS by QR. Now, by the given only I'm just checking. Check out. QT they have given. QT means this one. QT. What should be equal actually? QT for SCIS? QP should be equal. But what they have given? PR. Check out in the given. PQ and PR equal we made by by the given concept 1 equal to 2. So I can write here QT by QT by QR by QSC, QS by Q, okay, QS by or QR is equal to QT by what? QT should be equal to PQ by given only I'm deriving. Please don't get confused. Instead of PR, I can write PQ from 1, right? Not understanding? PQ. You say from 1. That is QS by QR. Therefore, QS by QR equal to PQ by TQ. QT I have written. QP it should be actually, right, but QP means RP. Okay. QP should come QP. Okay. Understand this, very important. Therefore, by SAS, check out PQS similar to triangle TQR by SAS similarity. I'll explain one more time. Just concentrate here. By the given ratio and given angle only, we formed the corresponding two sets. One angle becomes common that we can understand. I'll say henceforth. See, in PQS and TQR, if they're supposed to be similar, one angle is already common angle, so we can say that is equal. Actual side should come from the given part. If you observe, as is you can write. QR is just a reverse I wrote because the first triangle PQS I took, and so that triangle parts will be in the numerator. So QS by QR, it's already first part. QT by QR PR means instead of PR I just wrote PQ because 1 and 2 angle are equal, which means we derived from inequality opposite sides to the equal angles are equal. Okay, so so QT is also, see, these three parts are from given only. How did we write QP? Because it's equal to PR and PR was there from the given part. Okay, understood. Otherwise, what you can do is in this relation, first relation, you take the given part as it is. In the PR, you substitute PQ. That's it. Okay, I'll tell that also. Why we should not write whatever given ratio here means they're not corresponding parts actually. See, QR by QS equal to QT by PR. It is from given. But instead of PR, if you substitute PQ, we are done. QR by QS equal to QT by, instead of PR, we write PQ. This is from 1. Now these two are corresponding sides. Therefore, triangle PQS, very simply, otherwise you can say TQR by SAS similarity, hence proved. Okay. This is important question. Fourth one is important. And fifth one is also important. Sixth one is easy. We'll move to the next question. Fifth one. There is no figure for the fifth question. We have to draw the figure. It is most asked question, fifth one. Okay. Mark it as important in the notes and textbook as well. S and T are the points of the on the sides PR and QR of the PQR. We just draw the figure PQR. PQR. S and S is on PR. You say S is on PR. T is on PQR, right? Okay. I'll write other ways. PQR, usually we don't PQR. S is on PR, T is on QR. Means I'll just take T here. Just join them. They have given P is equal to RTS. Okay. Show that RPQ, big triangle, RTS, small triangle are similar. Okay. It's very simple and easy thing. We'll solve that. First write the given The angle is given, right? Equal. Thus we'll write that. Given P equal to RTS. Okay. Then to prove, we write copy from the question. To prove RPQ similar to triangle RTS. We will write the proof. Take the two triangles as is, what is to be proved, RPQ and triangle RTS. If you observe RPQ and RTS, R is a common. You just write R is equal to common. The other one they have given only. Check out. RPQ we have P RPQ only equal to RTS given. RPQ is nothing but P only. Don't get confused. This is same only. Okay. Otherwise, because why we have to write, please remember, while writing an angle, you should know when to write three letters, when to write one letter. When there is a confusion in the, see, I cannot write just a T angle because T means it may be RTS or STQ, right? So that's the reason I wrote RTS and P, which is given. Therefore, by AA, they're similar, very simple. RPQ similar to RTS by AA similarity. Okay. Pick the common angle. One angle they have given, use that. So by AA similarity, they are similar. We'll move to the next question. This is a 2 marks question, most frequently asked in many question papers. Sixth one will say, it's very simple. ABE is congruent to ACD. Don't get confused. It's not similar symbol. It's a congruent symbol. We have to prove the ADE and ABC are similar. Okay, we just saw the figure now. A, B, C, D, E is given. Join the bottom DC and EB. Given we write, what is given? Triangle ABE. ABE congruent to ACD. We write that ACD. To prove triangle ADE similar to triangle ABC. Okay. We'll start with the proof. See, since the congruent are given, the two triangles ABE and ACD are congruent means we tick the corresponding sides from that. Say CPCT, those two sides are corresponding. Use that in the similarity proving. Let's check out. So, since ABE and ACD are similar means we get AD and AE are equal. See, check out. AD and AE are equal, right? AD equal to AE and the other side is AB equal to AC. By since triangle ABC congruent to triangle ACD, that is the reason. Okay, by CPCT also. Okay, then we'll use that in triangle ADE and triangle ABC. What we can write is, check out, ADE and ABC we have one angle equal, which is that AI is a common angle. First you have to identify the common angle. Then two sides, AD by DB, right? AD by DB, you call it as 1 and 2. AD by DB, if you just divide the first two equations which we derived from CPCT one by one, you get the corresponding parts of the triangles which we need to prove similar. AE by AC. Because SCIS if you want to apply, two sides should be in proportion, right? So that two sides are derived as equal sides from CPCT. This is 1 divided by 2. Therefore, done. ADE congruent to, sorry, similar to ABC. AD by DB equal to AE by AD by AB. Because it should come with the big triangle ABC sides denominator. Therefore, by SAS similarity. Okay. Very easy question. Just only thing is, by congruency, you have to get the two sides equal, corresponding parts of the triangle. Divide 1 by 1, you get the ratio SAS, two sides ratio we get in the two true triangle parts. Okay. Thank you.